Welcome back. In our last video we covered how Splunk Edge Hub simplifies getting OD data into the platform. But what if your environment is completely isolated from the internet? Today we are tackling how to implement predictive maintenance in secure air-gapped networks. In a fully air-gapped environment, security is paramount. You can still use Splunk, but the architecture looks a bit different. Instead of sending data to the cloud, you deploy Splunk Enterprise entirely on premises, inside your isolated network. The Splunk Edge Hub sends data to this local Splunk instance using internal network routes, so no internet connection is required. Now, what if you need to get data out without opening yourself up to threats? This is common in critical infrastructure. The solution is a data diode, a hardware device that enforces a one-way data flow. In this setup, the Splunk Edge Hub sends data to the internal Splunk forwarder. That forwarder then passes the data across the data diode to an external Splunk instance. This allows you to get your OT data to an enterprise or cloud environment for analysis while making it physically impossible for any connection to come back into the OT network. A third option is to use secure DMZ or demilitarized zone. This is a small isolated network that sits between your OT environment and your external network. Here's the workflow. You place a Splunk intermediate forwarder into DMZ, then the Splunk hub sends its clean, normal set data to this forwarder. The forwarder then securely transmits the data to your main Splunk instance. The beauty of DMZ is that it acts as a control point. You can apply extra sanitation, filtering or aggregation to the data, ensuring that only essential data leaves the OT zone. So, whether you're fully air-gapped using data diode or DMZ, Splunk offers a flexible architecture to fit your security needs. Now that we have our data flowing securely, our next video will focus on the fun part, analyzing that data to predict failures. See you then!